Welcome to the online lecture series on 8051 microcontroller. In this video tutorial, we shall write a simple program to understand the working of a DJNZ instruction and its usefulness in assembly level language program. So as you remember, DJNZ is a looping instruction. Okay, just as you use for loop in case of C language, the same is about DJNZ instruction. It stands for decrement jump on non-zero. Okay, so we shall see this program. The program is write an ALP to complement the contents of accumulator 5 times. Okay, so you have to complement the contents of accumulator 5 times. Okay, so put some data in accumulator. I have put 55H. Then you have to complement how many times? 5 times. So write CPLA. CPLA, it complements the content of accumulator once. So CPLE twice, thrice, 4 times and 5 times. There is one way of writing, but is it feasible and is it good programming? He has given 5 times, it's fine. But what if it was 100 times? Right? A programmer cannot write a single instruction 100 times, right? Fine. So there comes the DJNZ instruction. Okay, now let us write the same program using the DJNZ instruction. Okay, now if you see the DJNZ instruction, okay, the syntax, it is decrement jump on non-zero. What should you decrement? You should decrement whatever the operand you have mentioned here. It can be Rn or it can be a direct address. Okay, and you jump to the location which is specified here. Okay, so how many times I have to complement the accumulator? 5 times. So first let me initialize the count. So move, I will take a register R0 comma hash 5. Now what is this? This is the count to complement accumulator. That is, I have to complement the accumulator 5. So the first step in DJNZ is you initialize the count. Fine. Then what should I do now? I have to complement accumulate. So I have done it once. Now we will use the DJNZ instruction. DJNZ. Okay. Then where is my count? It is in R0. So decrement jump on non-zero or 0. And if it is not 0, you go back and do the operation again. What is the operation here now? Complement accumulator. So I will say back. So where should be back? Back should come here. Okay. Then the last instruction is always the forever loop and end the instruction. Okay. We shall execute this and we shall understand the. Okay. So I have copied the data 55H into accumulator. Okay. And I have initialized R0 with a count of 5 because I have to complement the accumulator how many number of times? 5 times. Okay. Then I will complement the accumulator. Okay. Now let's understand the working of accumulator. So after complement, the result is again stored back in accumulator. Now after this, how does this work now? First is decrement. What does it decrement? It decrements the contents of R0. What was the previous content? It was 5. Okay, now it will be 4. So 4 is a non-zero number. That's why it's a non-zero number and a branching will be done. So this condition of jump on non-zero is true and hence branching will be done. So if I execute next, you can see R0 has become 4 and it has again gone back. Now it will complement once again. Now R0 will become 3. It will again complement. Fine. Now R0 is 3 now. It will become 2. still this condition is true, it will complement the accumulator. R0 is 2 now, if you decrement again, it will become 1. Now if you see R0 is 1, so already we have complemented 5 times. Fine. Now if I decrement R0, R0 will become 0. So when it becomes 0, this jump on non-zero condition becomes false. And what will happen? It will not branch to the branching address because the condition is false, and it will execute, it will come out of the loop and execute the next instruction. Fine. So that's about the DJNZ instruction. Okay. So you can try out one program which I will give it now. Write an ALP to copy the data FFH from memory location 30H to 35H. Okay. So will you do this or shall I? Okay. What you should do? So you have memory locations from 30H and 30H to 35H. You have to copy the data FFH. Okay. So how many memory locations totally? So 30H, 31H, 32H, 33H, 34H, and 35H. So totally 6 locations. 3, 4, 5, 6. Okay. So let me write for you. ORG 0H. Okay. So what is the count? 6. Move. You can take any register. I will take R2 now. Hash 06H. Okay, this is my count. Why it is 6? Because from 30H to 35H I have 6 memory locations. And see here, in this case you can make use of register indirect addressing mode. Okay, it will be more easier. Okay, one way was, okay, you simply directly copy the data to these locations. Okay, let me show you that. Okay, what I mean is, you copy FFH, say FFH, that is 0 FFH into accumulator. Then from accumulator you do move 30H comma A, then move 31H comma A, then move 32H comma A, move 33H comma A, this way. But is it feasible again? No, right? Now since I have 6 locations, maybe. But if I'm supposed to fill memory about 100 memory locations with FFH, can we do that? No, we cannot do that. So that's why indirect addressing mode is so powerful. It's a dynamic way of addressing the memory. Okay, so let's do that. So what I will do now, first I will copy the count into R2. Okay, and I will refer the memory using indirect addressing mode. Okay, what is the starting location of the memory? It is 30H. Okay, so I will initialize move R0 comma hash 30H. So I have initialized a pointer to start of the memory, that is the base. So 30H is the starting. Fine, I am done with that. Now what should I do now? I should copy data FFH to these memories. Okay, now that I have initialized a pointer, now I can say move at the rate of R0 comma hash 0 FFH. So 0FFH will be copied to memory location pointed by R0. Where is R0 currently pointing now? It is pointing to memory location 30H. Now once I have copied the data into 30H, now R0 should point to memory location 31H. So what will I do? I have to increment the pointer, increment R0. Okay, or you can say update pointer. Why? Because copying to 30H is over now. Fine, so we have incremented the pointer, and I should continue this unless I have copied until the last location. So I will say dj nz r0 comma back 1. So back 1 will be here. Fine, then you can end the program with this. Okay, so let's compile this and debug this program to understand this better. Now see, the starting memory location is 30H, so everything is 000. Okay, R2 I have initialized with 6. I have initialized R0 as a pointer to memory location 30H. What I am doing now, I am copying data FFH to R0. Sorry, to memory location pointed by R0. So R0 is currently pointing to memory location 30H. That is the starting location. So in 30H, you can see FFH has come. Now R0 contains 30H. Next I have to copy the data to next memory location. So I need to update the pointer. So I will increment. Now it is pointing to 31. So R0 contains currently, sorry, there is a mistake here. It should not have been R0. It should, because the count is in, sorry, there is a mistake. The count is in R2, right? So it should be decrement jump on non-zero R2. Okay. Let's keep this. Let's execute again. Okay. Now R2 contains the count. Pointer is initialized to memory location 30H, and you have copied the data FFH to the memory location 30H, which is pointed by R0. Now I am updating my pointer to point to the memory location 31H. As you can see, R0 contains now 31, and until where I have to continue, until 35H, the memory location 35H. Okay, so R2 contains 6 now, so I will continue this unless R2 becomes 0. Okay, you can see again in 31 FFH has come, so this will continue unless the count becomes 0. So R2 contains still 2, it is not 0. Now if you see, R2 contains what? 1, and you can see 30H, 31, 32, 33, 34, 35. All these memory locations have been filled by the data FFH. Okay, so then it will come out of the loop. Okay, very important programs I have discussed, and you should practice these programs. Okay, so I will give an assignment on this which you should do uh, using the software, or you can write up in the book, but see that you have written logically correct program. Okay, so the program is write an ALP to copy the contents of R7 to memory locations, memory location 30H to say 40H. Okay, a similar kind of program you have to write. So you have to copy the contents of R7 to memory locations 30H to 40H. Okay, please practice this program if you have PC. Okay, thank you.